Hello everyone, this is the last review for the Math 107 MATC that we're doing. And again, it's for anybody though who is looking at this, who's privy to the video and wants to look at some of the basic topics that are being discussed. There's 10 items here. Let's do our best with them and let's see where it's going to go. For number one, there is, and some of this stuff I'll have to defer to the actual content that's at the end of the video when it scrolls. You can actually look at the question there, and then it might be easier to draw. It's easier than having to draw it, so we'll just take it from there. There is a circle graph, guys, that shows how the annual budget for a company is divided by department. If the total annual budget is $7,500,000, what amount is budgeted for sales? Sales is 23%. So basically, they gave us the number in the pie chart there. The amount budgeted for sales is 23% of 7,500,000. And when you do this, you get what you get. So we've got the mathematics set up, so let's just at least go for it so we can get this thing out of here for you guys. I'm trying not to make the videos too long, but on occasion it is going to happen. I'll see what I can do. When you actually do the multiplication, guys, you're coming up with $1,725,000. Okay, and there it is. So, let's look at 2. 2, they are saying, okay, let's see how they actually wanted the thing here. Yeah, that's it. And for 2, the pie chart below shows how the annual budget for a certain company is divided by department. If the amount budgeted for editorial and sales combined is $10 million, what is the total annual budget? Well, editorial and sales, like I said, you'll look at this when it scrolls in the video, guys. You'll look at it when it scrolls in the video. For right now, let me just give you the information. It might be a little easier to look at that way. 6% of their budget is for editorial work, and 14% of their budget is for sales. So together, that's 20% of their budget is editorial, 20% of their budget, 6% and 14%. 6% and 14% is 6% for editorial work, 14% for sales. Together for sales and editorial work, it's 6 plus 14 is 20%. If the amount budgeted for editorial and sales combined is $10 million, what is the annual budget? Well, 20% of the annual budget is for editorial and sales. What is the annual budget? Well, the annual budget, I don't know what it is. I do know that 20% of it is for editorial and sales, and it comes out to $10 million. So let's see, these are some bigger numbers than I'm used to, guys, sometimes. Let's get this out of here. So you're basically saying, I don't know what the whole budget is. I do know, well, wait a minute. I don't know what the whole budget is. I do know that $10 million, is 20% of the whole budget. 20% of the budget, editorial and sales put together, 6% and 14%, 6% for editorial work and 14% for sales. Add them together for editorial and sales, 20% of the budget is editorial and sales. 20% of the total budget is for editorial and sales. 20% of the total budget is the $12 million allotted for editorial and sales. 20% of the total budget is the budget, and that 20% of that budget is $10 million. Well, 20% is 0.2. 0.2, 0.20. Divide by 0.20 on each side. There's a number of ways you can do this. Divide by 0.20, divide by 0.2. It's a lot of money. The whole budget is $50 million. Okay, so let's see. Let's confirm that where they are. Yeah, $50 million. Let's go to number 3. Three of 3. There were 24 participants in a recent study on personality traits. For number 3, there were 24 participants in a recent study on personality traits. After being shown 5 images, 1, 2, 3, 4, 5, image number 1, image number 2, image number 3, image number 4, and image number 5. Each participant selected the one that was most appealing to them. The image each participant selected appears below. Complete the frequency distribution for the data. So they got, basically, guys, they got this thing looking like, you know, they got the image and they got the frequency. It's image 1, image 2, image 3, image 4, image 5, whatever the images are. I'm looking at it, and let's see how many of ones I can see. And they'll have it, you'll see this when it scrolls at the end, guys. I see 1, 2, 3, 4, 5, 6. I see 6 of the 24s right there. For 2, I see 1, 2, 3, 4, 5. 5 right here. For 3, I see 1, 2, 3, 4. See 4 right there. Just make sure we got this. I mean, because there's a whole lot here, man. Yeah, it's there. For 4, there are 1, 2, 3, just 3. And for 5, there's 1, 2, 3, 4, 5, 6. Well, yeah, I hope it adds up. It does. 6 and 5 is 11. 3 and 6 is 9. 9 and 11 is 20. Plus 4 is 24. That's okay. Sounds good. There's the frequency thing they're talking about. You know, the image each participant selected appears below. Complete the frequency distribution. We just did that. That's A. B, these images are associated with 4 personality traits, but not every image is associated with every trait. The table below shows the traits and the images associated with them. How many participants selected an image that is associated with being optimistic? Well, optimistic, they say here, they got a table here. The optimistic trait is associated with image 1 and 4. Well, there's 6 people that chose 1. There's six people that chose 1, and there's 3 people that chose 4. 9. How many? That's it. That'll be the end of the story on that one, guys. So we got that, and that'll be it. Let me just see here. Like I said, you'll see this better. Those of you who are in my class actually have an actual record of this. Everyone else will also have a record of this because it's going to scroll at the end of the video. So let us see where that is. So that was this. Answers, and what did they say here? And then this guy, 9 participants. Yeah, there it is. Okay, good deal. So we're looking okay. Okay, we got all this for A, and we got all this for B. Okay. All right, for 4, guys. Again, it's all kind of all over. It's a lot of writing on this stuff. So look at what scrolls at the end, and we'll try to make sense out of this thing. Right now, I'll just verbally talk you through it. So when you do see the actual text, it's going to make sense as to what we do. 4 is ABC. So let's see how it's going to play out, you guys. For 4, a local recreational basketball league takes their statistics seriously. Luis, the league's data analyst, tracked the number of three-point shots attempted by each team over the last season. The histogram below shows the data. Use the histogram to answer each of these questions. What is the class width? Well, how wide is each class? We got 10 to 284. So if you subtract 284, if you subtract 210 from 284, you get 64. So on all of these, it comes out to 64. So what's the class width? We're going to say 64 units. Number of three-point attempts. So that's 64. B. According to the histogram, what is the total number of teams? Well, that's interesting too. The teams, you got to go all the way to the top and you know the frequency of the teams. There's 8 teams in the first part of the histogram. There's 3 in the other. There's 4 in the other one. There's actually, for the histograms, there's basically, for the first bar, there's 8 teams. The second bar, 3 teams. Third bar, 4 teams. And fourth bar, 8 teams again. So what you got here is, you've got 8 teams in the first bar, when you look at it, 3 in the second, 4 in the third, going from left to right, 8 in the first, 8 in the first, 3 in the second, 8 in the first, 3 in the second, 4 in the third, and 8 in the fourth. Just add them together. When you add these together, you get a total of 23 teams. So that's for that one. We got this. We got that. We got 23 teams here. C, how many teams attempted from 360 to 434 three-point attempts? Well, that's in the third bar. In the third bar, it's 360 to 434. From 360 to 434, that's the third bar. There were 4 teams that did that. So C is 4 teams. All right, and that should be problem number 4 for us as we're doing this. ABC on that one. We got 64, 23, and 4. Let's have a look. I'm sorry. Yeah, right. I have no idea how I got that answer there. That's got to be different. Yeah, I'm sorry about that. This is got to be 75 because I've forgotten how to subtract, I guess. You go all the way, so it's going to go 210 to 284. That's 74, but the next one starts at 285. So 285 minus 210 is 75. The other one goes from 285 to 359. Again, that comes out to 74, but it starts up again at 360. So 360 minus 285 is 75, and so on and so forth, guys. I have no idea how I got 64 out of there. Should have gotten 74 and then gone one more because it goes from where it begins, from where the first one begins until where the second one starts. From where the first one begins, from where the first one begins until the second one starts, and then the second one from where the second one begins, the second bar begins until where the third bar starts, and then from the third bar where it begins until the fourth bar starts. That's going to be 75. Everything else is on regarding this. Let's just see that. Yeah, it's a simple subtraction error. For some reason, I was thinking 74. I was thinking 64 when it should have been 74, but even then, you got to go to where the other one starts, and that's going to be 75. So start of one to start of the other, and that comes out to 75 in every instance. And to save my life, I cannot find. Yeah, there it is. So 75, 23, and 4. 70, yes, right there. 75, 23, and 4. Okay, looking good. Let's go to 5, ABC as well. A survey of 9 adults. A survey of 9 adults employed full-time was taken. Here are their reported numbers of hours worked per week. ABC, what A says, what is the mean of this data set? If your answer is not an integer, round your answer to 1 decimal place. B, what is the median of this data set? If your answer is not an integer, round your answer to 1 decimal point. C, how many modes does the data set have and what are their values? Indicate the number of modes by selecting the appropriate line and then indicate the values, modes applicable. Okay. Probably easier done than said, guys. Let's kind of be careful how we do this. For number, they've got 9 points here. The best way to do problems like this, where they're going to ask you for modes, they're going to ask you for a median, especially when they're going to ask you for a median, might as well just put them in line. From highest amount to lowest amount or lowest amount to highest amount, doesn't matter, but you got to put them in order. There's 9 of them, that should go pretty smooth. I'll go from smallest to highest. The smallest thing there is 46, to my knowledge. Let's make sure I don't make a mistake on this one. Okay, here's 46, and 46 is occurring 3 times. Then is 47. Then is 48. Then is 47. Then is 48. Then is 53. 3 times. Then this guy is 60. So we got 1, 2, 3. We got 1, 2, 3, 4, 5, 6, 7, 8, 9. What is the mean of the data set? If, et cetera, et cetera. Well, the mean is the straight out old-fashioned average. And the mean is if you add all of these and divide by 9, you're going to be there. So what you're looking at, let's see what we're looking at. We're looking at I got 50.222. I think they want it 50.222 going on forever. 50.2. Let's make sure let's see if I'm following the directions here. What is the mean of this data set? If your answer is not an integer, round your answer to 1 decimal place. And let's just see if we're agreeing with what they're talking about. They got 50.2. Not bad at all. 50.2. What is the median? Median is the middle of the list. I got 1, 2, 3. I got 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I'm on the 5 then. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah, 1, 2, 3, 4, 5. Yeah, landing there every time. The median is that. What is the question here? Is there 0 modes? Modes are the most frequently occurring. 0 modes, 1 mode, 2 modes. There are 2 modes. And there are 2. Let me just kind of write it like that. There's 46 and 53. And that's it. You should be looking at 50.2, 48, and 46 and 53. You should be looking at 50.2, 48, 50.2, 48, and 46 and 53. Sounds good. Let's go 6, 7, 8, 9, 10. Take it from there. All right. All right, guys, let's keep going. Six. Again, a lot of this stuff is going to look a lot. There's just a lot of stuff written down here, guys. It's hard to write it down within the context of looking at it right on a blackboard. Sometimes I'll do as much as I can on it, but luckily we are scrolling all the content at the end of the video. So look at that content and kind of match up what I'm doing there. It's just going to be a lot more time efficient for everybody, I think. Question number 6. The birth weights to the nearest pound of a sample of 38 newborn babies at a certain hospital are given in the following table, along with the number of babies at each birth weight. So they're saying some stuff here. Find the mean birth weight of these 38 babies. Round your answer to at least 1 decimal point. So there's this tally here, guys. There's 38 newborn babies. 38 newborn babies total, 38 of them. There are 6 babies. There are 6 babies, each one of those 6 weighing 5 pounds, or at least they list them at 5 pounds. That's 6 of them. There is 9 babies, each one at 6 pounds. There are 13 babies, each one at 7 pounds. And there are 10 babies, each one at 8 pounds. Well, if you add a baby, there's 10 babies, 13 babies, 9 babies, and 6 babies. That better be 38. 6, just add the ones I underlined. Just add the actual items I underlined. 6 and 9 is 15, and 13 is 28, and 10 is 38. Okay, that's 38 babies total. There is a frequency of 6 babies, each one weight 5. Frequency of 9 babies, each weight 6 pounds. This is all pounds. Frequency of 13 babies, each with weight 7 pounds. Frequency of 10 babies, each with weight 8 pounds. I add all these weights together and divide by 38, and that's going to be the average weight of the baby. Find the mean birth weight of these 38 babies. Round your answer to at least 1 decimal place. Well, okay, I mean, there's a lot here. What do we got? Well, what we got here at the end of the day is 6 times 5. 6 times 5 is 30. 9 times 6 is 54. 54 and 30 is 84. 7 times 13 is 91. 91 and 84 is 175. 175 plus 8 times 10, or 10 times 8 is 80. 80 and 175 is 255. So we got 255 divided by 38, and that should get us there. The mean what do we got? It's a neat question in its own right, I guess you could say. So let's see what we got here. Let's see what they got. $6.7105. Pounds per child, rounded to the nearest tenth. Well, that 7 ain't going to go anywhere, guys. That should be the number. Unless I made a mental mistake, which can happen. It can happen to anybody, right? And so it happens to me too sometimes, but it happens to all of us. So let's see if that came out okay. Yeah, they got 6.7. 6.7 pounds. You can write that in different ways. That's number 6. Let's go to number 7. Number 7, a veterinarian treated 7 dogs this morning. The list below gives the weights in pounds of each dog. 52, 24, 5, 72, 49, 52, 9. Find the range of the data set. The high minus the low. That's all it is, guys. So what we're looking at here, of those 7 dogs, the lightest one was 5 pounds. The heaviest one was 72 pounds. Lightest was 5. Heaviest was 72. I'm going to subtract. I'm going to get the range being 67 pounds. For number 2, let's see, have a look here. Just want to make sure we're following what they're, because again, mistakes happen sometimes. I just want to, if we're going to put this on film, let's try to get it to be okay. When we're doing it, 67 is what the answer is. So you're just taking the high minus the low, and you're good to go. Question 8 of 10. It's a neat question. The following are distances in miles traveled to the workplace by 6 employees of a certain university. 7, 2, 18, 37, 22, 22. Find the standard deviation of this sample of distances. Round your answer to 2 decimal places. Okay, let's take a look at this. Number of ways things can be looked at sometimes. If the number of items to be considered is very, very big, there's various approximations that can be made. Let's take a look at this. Let's see what we can do regarding any of this stuff. Okay, so we got all this. Let's see what we can say here. All right, let's take a look here. Let me do a setup on this, and let me just put this on pause for 1 second. I'd like to, and we'll talk. Let me just come right back, guys. Okay, guys, just want to check on a couple things before I went further with this, make sure everything's in line. For problem number 8, like I said that we were going to be doing, here's how the whole situation goes regarding that. Let me get my chalk here. They're asking a very good question here, and let's answer it. For question number 8, the following are distances in miles traveled to the workplace by 6 employees of a certain university. 7, 10, 18, 37, 22, and 22, all in miles. Find the standard deviation of this sample of distances. Round your answer to 2 decimal places. Well, these are the 6 distances. Each distance corresponds to a person who has to travel to work at the university. These are the 6 distances. And what I did was, and what we will do is, take these 6 distances, add them all together, and divide by 6, and we get the mean. The mean is x bar, and it's the top here is 108. There's 6 people. 108 divided by 6 is 18. Then this Greek symbol, letter sigma, means summation of every single one of these items subtracted individually from 18. So it's 18 minus, for example, that's the mean, that's 18. 18 minus 7, get an answer, square it. 18 minus 2, get an answer, square it. 18 minus 18, which is 0, square it and get your answer, which is 0 in that case. 18 minus 37, which is negative 19, square it, you get positive 361. 18 minus 22 is negative 4. The quantity negative 4 squared is positive 16. 18 minus 22 is negative 4. The quantity negative 4 squared is positive 16. When we had 18 minus 37, that was negative 19. The entire quantity, negative 19, was squared, giving you a positive 361. You're always going to get positive answers when you do this. So you're going to sum in that manner. You're going to get each situation, like I said, square it, then sum it to, you go to one of the items, there's 6 of them, go 18 minus 7, get an answer, square that answer. 18 minus 2, get an answer, square that answer. 18 minus 18, get an answer, square that answer. 18 minus 37 is negative 19. Get that answer, square the negative 19. You're always guaranteed a positive number. Even if it's negative inside here, when you square it, you get a positive number. When you're done, you take all 6 items, you take 6, you go 6 minus 1 and get 5. So whatever the sum is, divide it by 5. So you added all of these up here, got a pretty big number, I think it was like 770. You got 770 up here, and you divided it by 5. 770 divided by 5 is pretty interesting. It should be 154. The square root of 154 comes out to this. Let's just kind of confirm that. I'm just trying to remember I think it was 770 when it actually came out and we did it. Yeah, I think it was like 770 divided by 5, and we took this to the 0.5 power. Yeah, and that's 12.41. And there you go. That's number 8. Neat problem. If the numbers get really, really big, this n minus 1 is not too far wrong. This n minus 1 is not really too much different than just n. If the numbers are really huge, like a billion. A billion or a billion minus 1, they're pretty close to each other in size, so the answers aren't going to be too far off. But this is the setup that they want you doing when you're doing this right here. And this is for standard deviation that we talk about. And they got different symbols for that. Got the lowercase Greek letter sigma, and that works just fine. So that's number 8. Number 9. Here are the fuel efficiencies in miles per gallon. So this is number 9. Here are the fuel efficiencies in miles per gallon of 12 new cars. What is the percentage of these cars with a fuel efficiency less than 35 miles per gallon? Well, they write them down, guys. I'll let you look at it when they actually post this stuff. When they actually post this stuff, you can kind of look at it. But the numbers go 47, 36, 22, 18, 42, 32, 40, 55, 12, 28, 17, 35. What is the percentage of these cars with a fuel efficiency less than 35 miles per gallon? Well, there's a total of 12 cars altogether. How many of them have a fuel efficiency less than 35 miles per gallon. It's got to be less than 35. Well, 35 is equal to 35. Doesn't really work. 17 is less than 35. 17 is less than, so let's count this thing out. 17 is less than 35. 28 is. 12 is. 55 sure is not. Neither is 40. 32 is. 42 is not. 18 is. 22 is. That's 6 of them. So there's 6 of them. 6 out of that. So 6 out of 12. Pretty easy. That's 0.5. That's 50% is what we should be getting on that one for number 9. Okay, guys, almost there. So again, make sure. And again, you'll see this, the way they're actually listed, you'll see it. When you list it, you see the actual numbers that are there, and just count the ones that are that have less than 35 out of the 12. 6 out of the 12 have less than 35 miles per gallon fuel efficiency. Okay. They talk about number 10, which is a little messy side, but so let's just kind of just say this and be done with it, I guess. They gave a 2-part question on this one, A and B. Which of the following must be true about the Robinsons family? They don't give the answer on this one, guys, so we're just kind of use our best judgment on this one. We've got to at least find it. All right, guys. Number 10. Government agencies keep data about income distribution of the population. The Robinson family and the Adams family live in a county with 11,000 families. The Robinson family's income is at the 59th percentile. The Adams family's income is at the 14th percentile. A, which of the following must be true about the Robinsons families and Adams family's incomes? And they give these options. Well, the Robinson family earns more than the Adams family. Yeah, they're in the same county. If they're in the percentile, and we're assuming as far as like high earnings, 59th, who earns more? 59th percentile is, they're associated with making more money than roughly 59% of the people there. The other people are only making more money than 14% of the people there. The Adams are only making more money than 14% of the people there, roughly. Indeed, the Robinson family earns more than the Adams family. They gave some other options here. Both the Robinson family and the Adams family earn more than the median income. No, that's not true. The Robinson family earns $45,000. They didn't really, no, it's really, you can't really say that because we don't know what the actual incomes are. They're trying to put numbers on this when we're not given numbers right here. At least to my knowledge, they're not given numbers here. The Robinson family and the Adams family both have incomes in the bottom half. No. The Adams family does, but not the Robinson family. So the Robinson family earns more than the Adams family. That's for part A. Okay. So for Robinson's family, we'll say Robinson family income more than the Adams family income. You can write it like that. They didn't really cover this too well when they did this. Which of the following must be true about the Robinson family's income? Here we go again. The Robinson family earns more than 41% of families in their county. Yeah, they earn more than that, actually. About 41% of the families in their county earn more than the Robinson family. That'd be about right. The Robinson family earns 59% of the highest income in the county. That's not how it works. It's where they are in terms of they make more than 59% of the people that are there. But that doesn't mean it's 59% of the highest income in the county. The Robinson family earns about 41% of the highest income in the county. Neither one. The Robinson family earns, about 41% of the families in their county earn more. About 41% of the families in their county earn more than the Robinson family. Yeah. Earn more for that county. There it is, guys. That is it. Again, a lot of for this particular one, I think it's a lot easier to be looking at the actual figures that they have in there. It's a lot easier to look at them than for me to try to draw them on some occasions. But here we go. We got what we got. Take care. Thank you for your time. Do well.